We are looking at mixed designs, and in the previous video, we found that we were able to reject the omnibus null hypothesis and conclude that it did indeed looks as though row gain helps. That is, the pattern of weight of the hair is different for row gain, specifically more, than it is for the placebo. But now what I want to do is look at tetrad contrast. And I already, in the previous video, started kind of picking out where I might want to look at those tetrad contrasts. So I'm going fishing. I am going to use Chaffee's method to help me look at specific contrasts that I think might be of interest. So down here, what I'm doing is I'm getting a vector of means. And note, I have the two variables to take into account, treatment and time. And so therefore, I'm using this command with two factors with weight in order to get the mean and put it into a vector of means, which I can see here. So we already had those means way back up here when we did our descriptive statistics, but now I have them nice and handy in this little matrix actually. Why matrix? Because I have one vector for placebo right there, the control group, and one vector for the row gain group right there. The tetrads are part of the treatment time by time interaction. So the mean square used to test that omnibus effect is what we need for our mean square for the contrast. So we have a mean square residual up here, but that one is for the treatment. The one for the interaction remember is on this line, and the mean square that was used to create that F statistic of 3.4 was this mean square residual. So this was the mean square for the interaction, and this is the mean square in the denominator of the F ratio for the residual. So that 0.003337 is what I need to use when I calculate my variance for my tetrad. So also remember that there were 4 participants that went into each one of these means. Every mean you see here is based on 4 participants. So when I create my tetrad, it's going to be that mean square residual times the sum of 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4, which makes it quite handy in this particular calculation. That's just going to be 1. When I look at just this piece, it's going to be 1, which means that the variance of my tetrad is going to be the same as the variance I had for my residual up there. But that's just an anomaly, or a particular case. That's just the case because we had 1 over 4 4 times because of 4 people in each condition. So let me go ahead then and look at my variance of my tetrad. Once I have the variance of the tetrad, in order to get the standard error, I just take the square root. So let's go ahead and do that. Now for Chaffee, for the critical value, the omnibus F for interaction. Remember, I'm focusing on interaction. The omnibus F for interaction is based upon, under the null hypothesis, an F distribution with 4 degrees of freedom in the numerator and 24 degrees of freedom in the denominator. So here I'm getting an F quantile at 0.95 with 4 and 24 degrees of freedom. And then for my critical value for Chaffee, it's the square root of the numerator degrees of freedom times that F critical value. So that will give me my critical value for Chaffee. If I then multiply that by the standard error, which I got up here, so I've got standard error, I've got critical value, and if I multiply them together, I get μ. So now it's time to look at our various contrast estimates based upon tetrads. Now what I'm doing here is I'm actually, first of all, showing you the individual mean differences because, as I've talked about in the past, it's very difficult to talk about difference of differences in a way that's easy to understand. A whole lot easier if you just take each of those differences separately and talk about them and then create the difference of differences. So let's see what contrast I'm doing here. I'm comparing the changes from prior to the treatment to week 32. That is the last week. So if you look up here at our graph, we're taking the last week and comparing it to week 0. So how much change was there from the beginning of the study to the end of the study? And so I'm looking at differences. Look at what I've used here for my matrix. I'm using row 2. Let's start with this one right here. Row 2, column 5, and subtracting row 2, column 1. Well, let's look at what that is. Here's row 2, 5. That's treatment week 32. Row 2, column 1. That's week 0. So that first one shows me how much weight gain there was. That's hair weight. How much weight gain there was from the start of the study to the end of the study. Similarly, this next one is showing how much weight gain there is from the start of the study to the end of the study. And then I take and create my tetrad contrast, which is difference in the weight gains. So let's go ahead and do that. So row gain, the weight gain was 0.06. And let me remember what that was. I have it up here on the graph. Here it is. That's average daily weight gain in milligrams. So the average daily weight gain of the hair was 0.06 milligrams. That's in the row gain condition. The average daily weight gain in the placebo condition was 0.003 milligrams. Quite a difference. Much more hair weight gain for the row gain condition than there was for the placebo condition. The difference in those weight gains, if you take 0.061 minus 0.00325, is 0.058. So if you think about this 0.00325 as being baseline, and that's what it makes sense to do because that's the placebo condition. So rather than saying, oh, there's not going to be any gain in the hair weight, if you say, no, there's going to be some, what is it? The baseline is 0.00325. Now we compare that to what we actually got with row gain, and the difference would be the positive effect that is above and beyond the placebo that we got with row gain. And if we create a confidence interval by adding and subtracting mo, we notice here that the interval is quite wide. It's all the way from almost 0, negative 0.003, a little under 0, all the way up to 0.12, which is, by hair weight standards, that top one is quite a substantial gain in hair weight. So I don't have much to be able to say in terms of the tetrad confidence interval. I love this. I love being able to talk about what happened here in terms of my sample. So that's another good descriptive statistic that I can use. I don't have to just go back and use those individual means. I can talk about how much change there was from 0 to week 32 it was, week 32. I can talk about how much change there was in row gain compared to baseline. It's 0.05775. But in terms of a 95% confidence interval, I think what I want to report to the researchers is do a bigger study. My interval's too wide. Why? Because I have a lot of instability. Now that's concerning because that 0.05775 looks good, but am I confident I'm going to get this if I do the study again? Not really. Let's look here now. I'm going to compare week 8 to 32. Let's go back and look at what that would be like. 8 to 32. So I'm looking at week 2 to 32. All right, let's go ahead and look at week 2 to 32. And what we see is row gain by week from week 2 to 32 a gain of 0.03575, and a little bit of a loss for the placebo group, meaning a difference in favor of row gain of 0.04. But again, my confidence interval turns out to be too wide. What about week 16 to week 0? Why would I pick that one out? Well, look, week 16 is where it appears we had our maximum effect, right? Week 16 is where it seems to really maximize those differences. So let's go ahead and look at that. I'm fishing here. I can do that with Chaffee. I can look at the graph and make these decisions. And here I find a 0.051 milligram per centimeter squared gain in row gain above and beyond what I would get with placebo or a baseline effect. The confidence interval, again, too wide to be able to say anything. So I have some really good possibilities with row gain from my study I have in hand, but in terms of being able to make specific inferences, I'm a little bit worried about that. Even omnibus, remember, I'm a little bit worried because I haven't really met the conditions for valid inference. So the published did get, the published got studied. The study got published. The published study got studied by us today, but the study got published in spite of this. And in fact, it probably should have, as long as they did a quality study, because we are seeing something here. But I think also if I had been a reviewer of this study, I would have said, I really want to see you replicate this with a larger sample size so that you can get more stable estimates. Okay, so to review, the one between and one within subjects factor design. The units in the different level, the between subjects factor are independent. Units in the different levels of within subject factors are correlated. All levels of the within subjects factor are in each level of the between subjects factor, and the primary interest is the interaction of the between subjects and within subjects factor. Main effects are typically viewed as less interesting in this design, though the lack of interaction could prompt a check of main effects, although I would say in the study we were just looking at not really. It's not going to tell us anything. Mixed designs can be extended. You can include multiple between subjects and or multiple within subjects factors. I'm not going to do that. We're just introducing the mixed design here. In my more advanced classes, then I include multiple between subjects and multiple within subjects factors. But this is as far as I'm going to go here. Remember that the primary plot of interest is this mixed design interaction plot. Why? Because it shows the change across time and how this change differs for different treatments or conditions. So in this particular example that I'm showing you here, we actually had 4 conditions, and one is looking to see how things change in each condition over time. Assuming that a high number is a good thing, which I don't know without knowing more about the study here, I would say that that red line looks pretty promising because they start at the lowest and ended up tied for the highest. Okay, all I have left to do is take on my instructor challenge and construct a report. It's going to be about the data we just analyzed. I just need to add narrative and put it all together. So I'll do that in the next video.